Hello everyone, this is Nias. I am a PhD scholar in the Department of Electrical Engineering, IIT Madras. In this video, we'll be seeing about how to start writing programs in Atmel Studio 7 emulator for the Atmega8 microcontroller. This is a fundamental level video where I would discuss the fundamentals of playing around with the Atmel Studio 7 emulator. So the first thing is we have to install Atmel Studio 7 in our computer. So go to Google, search for Atmel Studio 7. Then you go to the corresponding website. Then you have the setup downloads in this one in this site. You can use either of this one depending on whether you have an internet connection or not. Okay, when you are installing. Then install Atmel Studio 7 based on the necessary instructions in your computer. When you have to open it, then go to File, New Project. It will ask for in what you want the project to be created, whether it's an assembly or a C or C++. Click on Assembler and give a project name. So here I am giving it as Program 1. Click on OK. If you want to choose a different location, choose a different location. Okay, because already there is a project by name Program 1 that is created. That is why. So maybe I'll create it as Program 2. Then it will ask for the device name. So give it as Atmega8. Click on OK. So a project by name Program 2 will be created, and by default there is an assembly language file main.assembler, main.asm, which also will come along with the creation of a new project. This is the writing of the program. So the first program is what we are going to write here is we are going to write an assembly language program to add two numbers. So this is the program which we are going to start off with. So whenever you are going to write a program, or what from my perspective, what you should always think of is you have to think of some of the below points which I am going to discuss with you. So we have to think of from a calculator perspective. When we are in a calculator, if we are going to do something, suppose we are going to add two numbers, what we'll do is from the keypad we'll write it as 2 plus, we'll enter the second number 3 equals, we'll get the result as 5. So in this case the 2 is an input which we have entered from the keypad. 3 is another input which also we have entered from the keypad, plus is the operation which we have to perform, equals gives the result. So in this case 2 and 3 are the inputs, plus corresponds to the operation. In this case it corresponds to the program which we are going to write, equals corresponds to execution of that program. So whenever we want to write a program, always we have to first of all think, that is as per my perspective, is you have to understand what all are the inputs. And how are you going to give? That means you have to see, okay, what all are the inputs that is required for the program, and from where are you going to give those inputs? Are you going to give it from a keypad, or you are going to get it from a sensor, or what exactly are the inputs going to come from? And the next point is what is the output, and where are you going to show it? So in a calculator, the inputs are coming from the keypad and the output is going to be displayed in the LCD display. So depending on the requirement, the task in our hand, this may differ. And the third point is the program which we have to write to achieve the required task. So in order to write the program, always try to have an algorithm. Take a piece of paper, write, okay, what all are you supposed to do? So these are the inputs coming from. So based on these inputs, what are the set of operations you have to perform sequentially to achieve or to arrive at the required output. So try to write an example. See what all are the operations when you're doing it by hand, then convert that into a sequence of instructions as per an algorithm or a flowchart. Once you have converted that, start writing the program in a piece of paper. So that is the way which I would suggest you all to follow. It varies from person to person. This is the way which I used to follow, which has been which has seemed very good for me. Okay, so let us write the first program in this Atmel Studio 7. So like I mentioned, since this is the first program, it's a fundamental basic level program where we have to add two numbers. Like I mentioned, point number one, where we have to understand the inputs and about how are we going to give. So the inputs I am going to define myself as, I am telling like the first number is going to be in R0, the second number is going to be in R1. So that is what I have defined, point number one. Then what is the output and where exactly are we going to have the output? So the operation is R0 plus R1 and I am defining it as like in R2 we should have the output. So we always we have to take an example, and it's always better if you are able to manually have at least some fundamental results. If you are able to manually calculate and have it would be always good rather than always taking the help of calculator. So if it is the numbers I am defining for cross checking, if I am going to write it as 0a, that which is the first number, 0b is the second number. When we add it after performing the execution, it should be, the result should be equal to 15, which should come in R2. So how we got 15? A corresponds to 10 and B corresponds to 11 in decimal. So 10 plus 11 is 21. In hexadecimal, it corresponds to 15. 16 into 1 plus 16 into 16 raised 0 into 5. So this should be the result. Okay, so let us write the program in the Atmel Studio editor. So like I mentioned, there is a main.asm file created along with the project. So in that, the instructions we have to write. So I have written like LDA, since R0 the first number has to be loaded. It is LDA R0 comma 0A, R1 0B is loaded. Then we have added R0 and R1. The result is moved to R2 and there is an NOP. So when you are doing this one, once you have written the assembly language program, the next part what you have to do is you have to build it. Building will convert this assembly language program into a machine level code. So you have to go to build, the first option, which is build solution. So that one you have to click. So you click build, there is the first option, which is build solution. You have to click on it, which will build the project. So while building the project, if there is any errors in the program, so it will show. So the errors are invalid register in line numbers 10 and 11. Since LDA is always associated with registers from R16 to R17, so that is the error which we have encountered. So since based on my definition, R0 has to have the first number, I am rewriting two more instructions so that R0 and R1 has the first two numbers. Again, once you have rewritten the program after correcting the errors, go to build, click build solution. So build one succeeded or up to date, there is no errors in the program. Then you are going to debug the program, since this is a simulation or emulation. So you are going to debug the program. Before that, what you have to do is either you have to go to this, there is a small hammer kind of icon in this part, custom programming tool. It may sometimes it may not be, there may not be anything written over there, but rather the icon alone. Click on that. Then you have to choose the programming, the debugger or programmer as simulator. Then after that, you again go to main.asm. So this is a simulator. Now we are going to debug the program. So whenever you are going to debug the program, since the values are going to be associated with the registers, or we are going to see the outputs and inputs in the memory or the registers or the IO ports, the program execution should not finish. If the program execution is finished when we are running the program, while executing the program, we won't be able to view the values of the registers or the memory or the IO ports. So in order to avoid that problem, you have to put a breakpoint. You click on the leftmost side of the program. Yeah, there is a red circle coming that corresponds to a breakpoint. Why we are giving this breakpoint is when you are running, the program execution won't stop. It will come and remain at the last line. So you are still inside the program, so that you will be able to view the values coming in the registers or the memory or the IO ports. Then once you have put the breakpoint, you go to debug. The second option, you may not be able to see it because it's not capturing the options when I'm whatever I'm clicking here. So you click on debug. The second option is start debugging and break. Click on that. So it will come, there is an yellow arrow coming, and it is showing like the first line, the program execution, it is remaining at the first line. Then this might be the way when you are executing, debugging the program. This might be the common windows that may be coming. One is the assembly language code, whatever we have written. Another one is the solution explorer, and another one is the memory details, like the different memories, the part of the memories which we can inspect: program flash, registers, data mapped IO, and so on, and the addresses. But in our program, one of the fundamental requirement will be to observe the registers. So in order to view the registers, what you have to do is you have to again click on debug. You have to click on debug. Then the first option, click on Windows. In Windows, the third option, processor status, you have to click on that. You have to go to debug. Again, click on Windows, click on processor status. Once you click on that, you will be able to see the fundamental registers and the values that are being occupied in that. So we have the XYZ register, the program counter, the status register, all are cleared. Then the values of the registers R0 to R31. So let us execute the program. Now the program execution is on the first line. So there are two ways of executing the program. Either you can click on F5, this one, continue. If you if you see this run button, it corresponds to continue. If you click on that, the program execution will stop at the next breakpoint. That is where it will stop. So, or you can go line by line. If you click on debug, yeah, and if you see the option step over, the shortcut key for step over is F10. So if you click on that, if you see that, so if you press F10 in the program, it will go line by line. So let me first of all go line by line. I am pressing F10. So it goes to the next line. So if you see, R16 should be loaded with the value 0A. So go to processor status and see what is the value of R16. R16 is 0A, and the program counter has gone to the next instruction. It's a 1 byte instruction. So it has gone to the next memory address 01, and it is going to execute. R17 should be 0B. That is the next instruction. So if you see, now R17 was 00. I am pressing F10, it becomes 0B. And again, program counter goes to the next memory address 02. 000102. Next instruction is move R0, R16. So R0 should be loaded with the value 0A. So if you see, R0 is 0A. Then R1 should be loaded with the value 0B. Then again, add R0, R1. So it becomes R0 becomes 15. Then R2 becomes 15, and the program has ended. So we have got the required output in R2 as per our requirement. So again, I am telling once again. You write the program, create this. You select it as a simulator here. Then go to debug, start debugging and break, it will run the program. And one of the most important aspects of writing any program is debugging. Debugging means when you have written a long program, after executing it, you may not be getting the required results. Okay, so one way to tackle this is by putting breakpoints in between. So you can have any number of breakpoints inserted in the program so that you can continue, you can execute till the breakpoints are encountered, and you can inspect the registers. That should be the way. So once you're doing like that, you will be able to debug the errors. So let me show it once again here. Rather than going line by line, you click on debug, start debugging and break. Like I showed last time, it comes to the first line. Now, rather than going line by line, we are going by pressing F10. Instead of that, you press F5. It will stop till the next breakpoint. Then you can view the values of the registers. Again, press F5. It will go to the next breakpoint. So this way, rather than going line by line, you can continuously execute. What you could observe also is the values of the status registers. So in this, the status registers, if you see, only the half carry flag has been set, because there was a carry from the lower nibble to the higher nibble, and rest of all the flags are reset. So based on the operation whatever we have performed, the status of the flag registers also can be checked in the status register inside the processor status window. So that was the first part of the program, the fundamental program, where we defined the inputs, we wrote the program, then we executed it, which corresponds to equals, like I mentioned in a calculator. Then we observed the output in the required registers. So that finishes the first basic. Now the second part of the program, the second program we are going to write. So we are going to write it as a separate program. So if you want to write a separate program in this project, go to the Solution Explorer, click on the project, right click, you select the option Add a New Item. So it will ask for what is the program which you want. The program name we have to give, it's an assembly language program. So we'll write it as main2.asm. Add. So already I had created earlier, that is why that message came. So first time when we are writing, it won't be there, so you add that. So this one here we are going to write our second program. So this is what I had mentioned at the start. When we are having a project, there may be multiple programs associated with the project. So we can add all those files here and finally link it. Linking, and I'm not going to show it this time. So so this is the second program which we are going to write here. So in this program, the problem with the earlier program what we wrote, the fundamental program, is the inputs we were defining inside the registers. So each time we have to change the value of the registers, and then only we can execute, so that we'll be able to see the output. One way to overcome that problem is either you have to give the values from the ports, or you have to define it in a lookup table. So here what I'm going to do is we are going to define it in a lookup table, the inputs, and we are going to execute the program based on, if you want to change the input, we'll rewrite that in the memory space where the lookup table has been created. So the second program, I am going to, you could refer to your manual. So in that, the second program, the inputs are going to be defined in the lookup table, labeled with the address, with the address label num. So we are having two numbers, D3 and 5F. So the two numbers have to be added, and the result has to be put in the SRAM starting at location 0x60. So this one we have to achieve. So in the second program, the inputs I am going to define in the address label num. The inputs are defined as two numbers, two bytes. So they are defined in D3 and 5F. So we need to load these numbers from the memory space, put it in registers, add it. then put it back to the locations in the static RAM, starting from 60. So defining of the code segment. So Z register, Z, X, Y, and Z corresponds to the registers pointing to the memory. So I am going to associate the, first of all, get the address of the lookup table, whatever we defined. The lower address goes to ZL, and the higher address goes to ZH, where the address label has been defined. So we'll get that address. Then let us load the values. So we'll load from program memory into one of the registers. Anything you can take. So let me load it to R3. This definition you have to do at the start in order to make the write the program in a better way and to avoid confusions. So we are loading it into R3 from Z, and once you load it, the next byte you have to take and load it into maybe R4. That is my definition. So R3 and R4 we are having the values. Then add both. So the result is now in R3. Now there is a condition when we are adding. If you are adding two numbers, suppose you are going to add between the numbers 0x0a, like in our earlier case, or 0a and 0b, the result was equal to 15. That is our first program. Now if you add ff plus ff, the result is going to be, so f plus f, so this is 15 plus 15 is 30, so that corresponds to 1e, so 31. So 1fe, this is the result. But when you are adding the two values, so ff and ff in the two registers, you will get fe as the result in the register. This one you won't be getting because it's an overflow. So that overflow will be shown in the carry flag, which we have to, that overflow will be shown in, so that overflow will be shown in the carry flag. So if the carry flag is set, then we have to we have to take that one, we have to insert a 1 in one of the registers and store it in the memory location, because carry flag is a 1 bit, but our result is going to be in byte form. So we have to write that rule in the program. So what we'll write in order to take care of that condition, so we are going to load one of the registers R16 to store the higher value. So initially we are going to initialize it as 00. Then we are adding between the two numbers R3 and R4. If there is no carry, branch if no carry to no carry label. So in no carry label, there is no change. We are going to store the results. So store the result in the static location pointed by x. So we have to write like st x plus comma. So where our results are R3, then st x comma R16, which corresponds to that carry. So we have to define x also here. So how we will define x? LDI x h xl comma 0x60, where we have to give our output LDI xh comma 0x00. So x corresponds to 0060. We added the two numbers. If there is no carry, it comes to this instruction. If there is a carry, what we will do? LDI R16 comma 0x01. So if there is no carry, it comes to this label and it will store the result in that location 0060, and then x will be incremented followed by the value of R16. If there was no carry, then R16 value will be equal to 00, which we which we had initialized at the start. Otherwise it would be set to 01 and that would be saved. So end of the program, NOP. So save it. Once you save it, since there are two assembly programs which we have written in our program, in our project. The first thing is you have to build it. Sorry. So before building it, what you have to do is, which program has to be set as the entry file. Entry file means which program will run at the start. So you click on the second program, then set as entry file. You have to click it, because otherwise the first program whatever we wrote, that would be the entry file. You can see by a down red arrow. So you have to change it, otherwise the other assembly program would be run. So set as an entry file, then you go to build solution. So there is, it is written like brnc is an unknown instruction or macro. So there is a problem with so there is a problem with the instruction which I have written. So the instruction was branch brcc. So brcc, it would come to this one. So let's once again build it and see. So build is succeeded and it is up to date. So what we can do, again you put a breakpoint at NOP, then you start debugging and break. So the values you can see. So if you see the value of ZL F10, I'm going to go line by line. F10, so Z register, it is 001A. So that is the value of Z register. So if you see so the value of Z register is 001A. So if you go to program flash, the memory window, program flash, if you check 001A, the location 001A, that is where we have defined our lookup table, the inputs as D3 and 5F. So let's see whether we have the inputs there. So you go to 001A in address and click enter. So if you see 001A corresponds to D3 and 5F, which are our inputs, D3 and 5F. Now I'm again taking it back to 00. So let us see the value of the registers. So R3 should be loaded with what value? D3. So this is R3 initially 00 plus F10. D3 has come to R3. Then R4 should be loaded with 5F. So R4 has been loaded with 5F. Then XL register is 60. XH is 00. So X register has been loaded with 0060. So add R3 and R4. So when we are adding D3 and 5F, the result is 3 plus 15, 18. So it is 1, 2. So 13 plus 1, 14. 14 plus 15, 19. So 132 should be the answer, where 32 should come to R3. If you see R3, it is 32 and the carry flag should be set. So the carry flag is set. So here it will check whether the carry is cleared or not. So the carry is not cleared. So the R16 value which we have initialized as 00, so it comes to the next instruction, because there won't be a jump. It will go sequentially to the next instruction where R16 will be set to 1. So we got 1 and 32, 132 as our value. Then X R16 will be saved to X. So sorry, R3 will be saved first of all to X. So in the static RAM location 60, the value would be 32. So in 0060 in data registers, if you go to that memory and observe, it is 32. And the next location should be loaded with the value 01. So 0132. That is the answer which we have obtained. So this is how we have debugged the program. You can go line by line and see, or you can from the first line you press an F5, it will come and stop at the last location. So that is how we can see. So if you want to see the data registers other than the processor status, you can observe here also. So in the data registers window, in the memory window, if you see, this corresponds to R0, R1, R2, R3. R3 is 32, that is coming here. Then R4 is 5F, that is coming here. So like that we can observe the data register values here also. But the problem is you have to count and see, okay, what is the memory address based on which you have to associate the register. So if you observe in processor status window, it would be easier. So quit the debugging window, change change the input AA, maybe it becomes 1b. So A and 1B. So what should be the answer? A is 10, 10 plus 11 is 21 is 15. So 5, 1 plus 1, 2, 2 plus 10 is 12, 12 is C. So C5 should be the answer, 0, 0, C5. So let's see whether we are getting that. So start debugging and break. I am going to press F5. So it has come here. So C5, R3 is Z5, and R16 is where our carry, that is 0, 0. You go to the register location, memory location 60, and observe it should be 00C5. That is the answer. So this is the way you can write a program, compile it, debug it, and observe the output in Atmel Studio 7. So this is a fundamental examples, two fundamental examples which we have seen. You can write a you can write a program to achieve your required task in n number of ways. That is up to you what you want to follow. But what I would suggest is always have a clear idea of what are the inputs, what are the outputs, and where exactly are we going to define it, followed by writing an example of how you are going to achieve it, followed by converting that to an algorithm, then the program. So that would be easier for you to have a clear understanding of the program. So just wanted to mention about these two instructions. So the memory space, when we are defining the lookup table, those are word addressable. But whenever we are loading the values, it is a byte addressable location. So to convert that, we are using these instructions. I hope you are clear with that in your, based on what sir would have mentioned in the class. Just wanted to tell you, okay, that is the reason why we are converting the word addressable memory locations into byte addressable and taking the values. Now continuing with the first experiment itself, you are the first part, addition of the two 8-bit numbers, already we have discussed. So I have given in the manual, like, okay, where are the inputs and the outputs defined. Then you have to divide two 8-bit numbers, that is the next program, multiply the two 8-bit numbers. The inputs and the outputs are already defined in the manual, so you can take a look at that and write it. And the next program is the 16-bit addition. So you will define the 16-bit number in two consecutive locations, the two numbers followed by the outputs. The next program is compute the odd or even. So that is what this 5 programs is what you are supposed to do. Not 5, there is one more program. So we have to, given a set of 8-bit numbers, we have to compute the entire sum and store and display the results. So it is mentioned as problem 4, which is problem 6. So the inputs will be the count of numbers, then the numbers you have to give the outputs. So this 6 programs you are supposed to do. If you are having any doubts, you can always give me a call or send a message in WhatsApp. uh, I would try to clear it out. Thank you.